Hello and welcome to this webinar concerning concrete section. My name is Fredrik Lagerström and I will be presenting this webinar. And normally I work as a product owner for Prestress and technical support for Prestress and WIN-Statik, and I also help with the FEM design support. But today we are looking a little bit at concrete section. Today we are using the GoToWebinar interface. So if you have any questions, you are free to ask them in the user interface that you have on your screens, and they will be answered after the presentation. There is an option for raising a hand, but I will not be checking this during the presentation, so it is much better to ask the question and I will be able to answer it whenever it is that I seem that it is okay to do so, most likely after the presentation. The presentation will be recorded and will be made available on the Strusoft YouTube channel, and it will be uploaded later today. The questions and answers session will not be recorded. So if we take a look at the agenda, what we are going to talk about today, we are talking about concrete section. And this is a small program that will be calculating reinforcement using the section forces. And it is possible to analyze several different sections for one set of forces. We will go through the analysis part and the design part. We will take a look at the cross sections, loads, long-term effects like creep and shrinkage. We will take a look at the materials, how the reinforcement is entered, either by designing, and there you have to give the reinforcement details, or that you analyze one set of reinforcement and how that is used to input in the program. We will take a look at the calculation and then at the results and the presentation of the results. And after this, we will have questions and answers where I will try to answer most of your questions. The initial settings or the interface that you are presented with at the beginning is where you have to choose the code and the national annex. And as for the code, we are using the Eurocode. And as for the national annexes, we have a set of 5 or 6 different annexes. There's also a possibility to use simple data, and this means that the program will give one ultimate limit state, one long-term and one short-term serviceability limit state. But it is possible to unselect this, as we will do in the presentation of the software after this PowerPoint presentation. And we will give the section forces ourselves. There is a selection in the top of the screen where you can either select to design or to analyze your cross-section. With the design, you enter the reinforcement details, while in the analysis, you enter the reinforcement and then we get utilization. If we look at the cross-sections, you can select one cross-section to use in the calculation, or you can set several different cross-sections. And we are only looking at one set of loads. And here it is possible to set up a lot of different sections to analyze for this set of loads. When we take a look at the loads, we have different types of load combinations. So we have the ultimate limit states or the serviceability limit states, and we enter the values and for the section forces that we have. When we take a look at the serviceability limit state parameters, like creep and shrinkage, for the ultimate limit state, we are using the effective creep coefficient, while in the serviceability, we have the normal final creep coefficient and the shrinkage of the cross-section. If we take a look at the material, this is quite an ordinary window for all the WIN-Statik software, where we can select exposure classes, strength classes, and the different kinds of reinforcement to be used. This window will look a little bit different between the different national annexes, depending on the settings of that national annex. As for the reinforcement details for the design, here we say what kind of diameter for the reinforcement at the bottom and the top we want. And we also enter the concrete covers. And in the left part, we can see the covers that will be used in the software, while the blue values are the concrete covers according to the code. And it is possible to design to enter different values here. But if you want to design, then the reinforcement values need to be according to the code. Well, if we take a look at the analysis part, it is possible to not use the code values, but to actually analyze an old beam, for instance, that was not in use with the Eurocode design. On the right-hand side, we give the stirrups, what diameter of the stirrups we would like to use, and the angle of the stirrups. And if there is any torsion in the cross-section, we need to define longitudinal bars as well. That will be acting as the torsional reinforcement. When we take a look at the reinforcement in the analysis part, we have this window looking a little bit different. Then we define the position of the reinforcement, what diameter it has, and what kind of type it is, where we have B for bending and L for shear, or actually torsion. So it's the longitudinal bar that we define there. And here it's also possible to define the stirrups. So we define the angle, and we also define the diameter and the spacing in the element that we are looking at. If we take a look at the calculation settings, here there are different settings, like use the minimum reinforcement if we want to design with minimum reinforcement. We also have the possibility to design it according to Eurocode EN 1992-1 9.2.1.1, which is basically saying that this is a secondary element and there is some risk of brittle failure that is accepted, and that means that we don't have to use the minimum reinforcement according to the national annex, but we can actually take 1.2 times the reinforcement needed in the ultimate limit state. It is also possible to consider the current section cracked, and that will also affect the capacity. There are some calculation settings for the iteration needed in the software. This is a setting that is not used that much, or that the user needs to change, but it is usually normal to just use the default values. As for the tensile strength of the concrete in the serviceability limit state, it is possible to set different values of the tensile strength here. And here on this picture, we can see the Swedish national annex, where they actually have 3 different types, while in normal Eurocode it is FCTM and FCTM FL. It is also possible to set the cotangent theta value here in order to use the shear capacity of the stirrups correctly. And it is possible to design using stirrups and without any stirrups. In the calculation that we will be taking a look at further on, it is possible to see the different information here, if there are any errors or if there are any warning messages in the serviceability limit states. If we take a look at the results, there is one quick result that is showing when we've done the calculation, where you can just see the amount of reinforcement that was needed in this design, and with regards to bending and with regards to shear. It is also possible to get the detailed printout, and that is shown in the bottom of the application, and that will be updated when you do the calculation. This printout can have different detailing levels. So in the printout options in the software, it is possible to set different levels, like limited, normal, and increased. And here it is possible to also manually set the different results by clicking on them, and you get a printer icon in order to get those printed. So now it is time for the actual presentation of the program. So I will be starting with WIN-Statik Launcher. And this is a small software that will be installed alongside any of the WIN-Statik software, where you can quickly start the software. You have access to different help videos and also a good set of links for the Strusoft portal, support, newsletters, webinars. It is possible to view earlier webinars, to open up the Strusoft installer that is used to update the software. And with the Strusoft installer, it is possible also to see if there are any updates for the applications that we have. And if we take a look at the WIN-Statik concrete section, I am using the latest version, but it is possible to see if there has been any updates for the version that you have installed in here. And it is shown in black, and it will be saying update here on the left-hand side if there is an update available. Now I will start the concrete section, and it opened up on the other screen, of course. So I will start up a new one here. And this is the presentation of the initial set that we do, and we can here select Eurocode, and it is possible to use British, Danish, Swedish, Finnish, and Norwegian national annex. Today we will just be using the normal standard Eurocode. It is possible to select this simple data, but I will not be using this today as I will be entering all my load combinations by hand. And now in the software, we can see the different program modes of design and analysis. And I will start with designing one cross-section, and then we will take a look and analyze another section to see if that actually fits the section forces that we have presented. So first step is to select the different sections that I want to use. So here in the section database, we have the different concrete sections, and in the standard Eurocode concrete, we have a set of different cross sections that can be used. And there are examples of all the different sections here. It is also possible to design a non-standard concrete, and this is basically the user interface or the user database. And it is here that I will be entering my different sections. And as for the rectangular solid, I can add, and in this case, I will be using rectangular beam 60 by 80. It is also possible to get the information from previous other sections. So I can select another section. And I will just give it another name. I will add this one, and I will also add the 400. So I will start with the first beam, and then it's shown here. I can add more by selecting them. And in this case, I now have the 3 different sections that I would like to analyze. I will select the 800 and use this for the initial design. If we go into the load cases, it is possible here to link different load cases, and this basically means that I will link all the load cases shown here to the cross-section that I have, but it is possible to define different parameters for different sections for the same set of section forces. So I will start with an ultimate limit state. I will enter my section forces. And as for the axial force or the normal force, it is important to see that if it is in compression, you need to enter it as a negative value. I will enter a few short-term or one short-term load. I can select the limit state and what kind of type it is, if it's a short-term or long-term load. Now that when we notice the shear forces here, it's guarded by these fences on the right and left side. And this means that the shear force will not be used for the design, but it's merely there to show what the shear force is for documentation purposes. When we have defined all this, I will link my load cases. And this now means that I will use all these load combinations on the cross sections shown here. If we go into the long-term loads here, I will enter the creep or effective creep in the ultimate limit state. And I will enter the shrinkage as 0.4 per mil. And as we can see, it's only the ultimate limit state where we have the effective creep, and in the long term that we enter the creep and the shrinkage. As for the material, C3037. Here it is possible to set what kind of reinforcement you would like to see. The K500 CT is the normal reinforcement, and here we have pre-stressing strands, but it's not possible to design any pre-stressing elements here in concrete section, but it is possible to add the reinforcement. When we take a look at the reinforcement details, I will use diameter 12 in the bottom and diameter 16 in the top. And here it is possible now to see what kind of covers I will use and what the code says. And if I in the design would use a lower value, let's say 27, then there will be an error in the program, and that is if I have the code control checked. So if I don't have it checked, I can actually bypass the warning, but it's usually recommended to have the code control active so you don't enter any wrong values. Here we will set the aggregate size as well. And now we can see that the distance between the bars will also be affected, and I will actually use the wrong values here of 20 instead of 21, so we can see what happens if I would get this error. As for the stirrups, it is possible to set them here, and it will also affect the code values here. I will use diameter 8 in this example. As for the longitudinal bars for the torsion, I will use diameter 8, so it is possible to distinguish between the bottom and the top reinforcement in the cross section when we are doing the design. For the calculation settings, here it is possible to use compression reinforcement if that is present, and we can use the minimum reinforcement, and I will use that one today. It is also possible to set this as a secondary element, and here is a small question mark where it is possible to get a little bit more information about how the calculation will be performed in that case. It is also possible to set this as cracked. I will not use that for the design today. Here I can set the concrete tensile strength, and I will just use the FCTM. FCTM FL is more used when we have pure flexural bending in the cross section. When we are done with that, we will see that the active load combination will be the ultimate limit state. While if I should have been standing in the short term or the long term, it is not possible to actually calculate and design. But here in the ultimate limit state, I will design, and I will press calculate. No. Oh. There seems to be something wrong in the software, so I am not actually able to calculate the torsion part in this version. So we will take a look at the analysis part here, and here I will be able to enter the reinforcement. I will be able to define the stirrups, as what spacing they have in the analysis part here. And I will be able to calculate. And here we can see the that the analysis part actually gives that this is not okay, and it is because I don't have any longitudinal bars dedicated to the torsion. And now it's actually set the reinforcement of the stirrups here for the design part as well. And now when we take a look at the results in the design, we can see that I have my top reinforcement and I have a lot of longitudinal bars all around the cross section in order to take the torsion. So here we can see the bending results now with the stirrups, and I have the results for the shear and the torsion is shown here. I think that the stirrups was not set when I installed this latest version, but I actually needed an analysis to set the reinforcement here, and this actually set the possibility to draw the reinforcement here and able to calculate it. And here we can now see in the analysis all the positions of the reinforcement bars. It is also shown here in the printout options. And if I print it, here we now have the possibility to see the results here. And we have the different calculation settings that we have used. The serviceability limit settings for short term and long term. And we have the different results here. So here it is possible to see the amount of reinforcement needed. So I need 7 diameter 12 and 16 diameter 10 for the bottom and the torsional reinforcement. It is also possible now when I have the results here. So if I select a lower cross-section, I will make an analysis of that. And yeah, there is a warning now with the invalid cover at the side. And this is due to the cross-section has actually just cut away the reinforcement here on the top and are using the bottom reinforcement. This is actually okay to use the 700 high by 600 wide. And if I would go in and take a look at the smaller cross-section here, calculate it, and here it shows in red that it is not okay to use this. So with this, these forces, then it is possible to see that the smaller cross-section is not okay to use, but I can use the higher ones. So this concludes the presentation, and the next webinar in English will be a concrete column, and that will be presented on the 2nd of November. And thank you for attending.